Hello and welcome to the review for the final exam for your college algebra course. In this video, we're going to be going through the first 10 problems. Let's get started. So for question number 1, it wants us to graph the function, write the domain and range in interval notation, identify the transformations required to graph the function. All right, so here we go. If we slide this up a bit, the first thing I notice is that there is a -3 at the back of the function. Notice that this -3 is outside of the absolute value, so that makes it a vertical shift. Plus is up, minus is down, and so this is going to be a shift down 3. We have a -1 inside the function. That is a horizontal shift. Plus is left, minus is right. And so now we can complete the transformation section. So we know that this graph is going to shift down 3 units and to the right 1 unit. Now, once we know the transformations, it should be super easy to get the graph, because we know that a standard absolute value makes a V centered at the origin, but our graph is going to be shifted down 3 and right 1. So if I go down 3 and right 1, then our V is going to be here. That is the vertex shifted down 3, right 1. The fact that it's an absolute value is what makes the shape a V. And now that we have the graph, we can get the domain and range. So the domain is going to be all real numbers in interval notation, that is -infinity to infinity. And the range, going from bottom to top, we can see the lowest that the graph ever gets to be is -3. And we use a bracket because -3 is included. And this graph will go up forever. So again, the domain is from left to right. And since the graph spreads out forever, left and right, the x values that exist are going to be all real numbers. And the range are the y's from low to high. So from -3 up to infinity. And that should do it for question number 1. Question number 2. They want us to find 3 function values. And just so you know, there are 3 pieces to plug into. And what's going to determine which piece you use is the value of x that you plug in. So for f of -5, we know that -5 is less than 5, so that makes this true, and so we're going to plug that into the top piece. Replacing the x with -5, that's going to give us -20 plus 1, which is -19. And if I get rid of these check marks, next we're going to do f of 0. And from the test zone, we can see that 0 is also less than 5. And so that makes the top piece true again. So we're going to plug 0 into the top piece. And that's going to give us a 1. And last but not least, f of 15. Whoops. And we can see that 15 is greater than 10. So now the bottom piece is true. And so we're going to plug 15 into the bottom. 5 minus 5 times 15 equals. Calculator time. 5 minus 5 times 15. -70. And if I didn't make that clear, Let me go back and explain one more time. Maybe even using a different color would be good. So this right here is what I call the test zone. And you have to test each x to see where to put it, okay? So the -5, when we did -5, that was less than 5, which goes in the top piece. Next we did 0. 0 is less than 5. That is also true, top piece. And then when we tested 15, 15 was greater than 10. And so that's why we use the bottom piece. And I hope that helps you see which piece you decide to plug into. Notice that we did not get any x values that were between 5 and 10, and so we didn't get to use the middle piece. And that's going to do it for page 1. Now, on to page 2. Going all the way up to the top. It says, for the pair of functions, perform the indicated operation. They want us to find f divided by g of -4. And so what that means, it means we're going to plug -4 into the top piece, and the top piece is f. And in the denominator, we're going to have g of x evaluated at -4. So we're replacing every x with -4 in g of x. And then all I need to do is work this out and simplify my fraction. Let's see, that's going to be -20 minus 4 is a -24. And I'm going to use my handy-dandy calculator for the denominator, using my Casio FX 115 ES Plus. Gives me 10. And then we just need to reduce that to lowest terms. So 24 divided by 10 in lowest terms is a -12/5. And go ahead and leave that improper. That's the way I like it. All right, number 4 wants us to find f minus g of x. And so that says that we're going to take f of x and we're going to subtract g of x. Notice that I'm putting the g of x in parentheses, and that's because we're doing subtraction, so that minus has to distribute. And so that's going to give me 3x squared minus 5x minus x squared plus 3x plus 10. And then I need to combine like terms, okay? So we've got 3x minus x, 3x squared minus x squared is a 2x squared. I've got a -5x and a plus 3x makes a -2x. And my plus 10. And that is the answer simplified completely. You don't need to worry about factoring the answer. Next, perform the following polynomial division. Okay, this is going to be long division. And so what we want to do is take our x minus 5, and we're going to divide that into, what did I say, x? It's r. R minus 5, 7r cubed minus 26r squared minus 40r minus 25. And I do want to make sure you understand that under the dividing symbol, all of that stuff, that's called the dividend. Every power of the variable has to be represented. So if you start with r to the third, then you also have to have an r squared, an r to the 1, and a constant. All of those terms have to be represented. If any of those are missing, you need to fill in a 0 placeholder. All right, so the first step, we're going to take 7r to the third and divide it by r. That's the leading term of the dividend and the leading term of the divisor. If you divide those, that's going to give you the first term of your quotient, which is going to be 7r squared, okay? So just so you understand, the leading term of the divisor and the leading term of the dividend, you have to divide those to get your 7r squared, to get your first term of your quotient. Okay, next step, we're going to need to take this 7r squared and distribute. That is the next step. So 7r squared times r makes 7r to the third. And 7r squared times -5, that is a -35r squared. All right, now listen, pay attention. When I draw the line, I need to change the signs. Draw the line, change the sign, and then combine. 7r cubes are going to cancel. What is 35 minus 26? Is that 9? Let me check. Yeah, that is 9r squared. Now the minus 40r comes down, and then we rinse and repeat. Now we're going to do 9r squared divided by r, and that is the second term of the quotient, 9r. And then the 9r needs to distribute just like the 7r squared did. 9r times r makes a 9r squared. 9r times -5, -45r. Draw the line, change the sign, and then combine. Gives me a 5r, and the minus 25 comes down. So far, so good? Now, last step. We need to take the 5r and divide it by the r, okay? And I'm really scrunching this stuff up here. So let's write it like this. 5r divided by r. r's are going to cancel. Leaves me a 5. That is the last term of the quotient, okay? And now we need to distribute. So that's going to be 5 times r is 5r. 5 times 5 is 25. Draw the line, change the sign, and then combine. And so we get a quotient of, let's just write it like this, the quotient, oh my gosh. The quotient is 7r squared plus 9r plus 5 and a remainder of 0. And that should suffice for doing the long division. Number 6, function composition. G circle f of -7. Here's how this works. First, we're going to rewrite using nested parentheses and then plug and play from the inside out. So the first step is to plug -7 into f, right here, in for every x. That'll be -5 times -7 minus 9, and then we need to work that out. And so what does that make? That is 35 minus 9, which is 26. And then we need to plug 26 into G. And so that's going to give me -9 times 26 squared minus 8 times 26 minus 8, and then plug in all of that into the calculator. Here we go. Being real careful. Plugging it into the calculator, the Casio FX 115 ES Plus. is what I use. Whoo, negative 6,300. That is a big negative answer, but don't feel bad if it's big and negative. Those are numbers too. All right, moving on. Next page. Number 7. For the pair of functions, find the indicated composition. And so this time we're finding f circle g. That means we're going to do f of g of x. And that means that we're going to plug the entire function g of x into f for every x, okay? And so what is that going to give me? That's going to give me 4 times x minus 7 squared plus 4 times x minus 7. Do you see what happened? I replace each x with x minus 7, and then I'm going to need to work this out. So x minus 7 squared means x minus 7 times itself, which is going to indicate the FOIL method. And the 4 here can distribute, all right? So up here, bam, up here, we're going to continue that out. All right, so I'm not perfect, I'm sorry. Plus 4x, 4 times 7 is 28. Now we'll continue that up here. That's going to be 4 times, doing the FOIL method, x times x, x squared. On the outside, minus 7x. On the inside, minus 7x. Last but not least, plus 49. And then the plus 4x minus 28. Whew. All right, so we're going to have 4 times x squared. I've got to combine my like terms. Minus 14x plus 49 plus 4x minus 28. And now the 4 can distribute. 4x squared minus. All right, so what is 4 times 14? That is 56. And 4 times 49, that is 196. Plus 4x minus 28. And last step, doing a little CLT, combine like terms. We've got a 4x squared, we've got a minus 56x, and a plus 4x makes minus 52x. And we have a plus 196 minus 28. 196 minus 28 is 168. Whew, and that was a long, involved problem, but that is the answer, and that's how to do it. Next, number 8. For the following function, construct and simplify the difference quotient. And they actually give us the formula for the difference quotient right here. And so the first step, if I was to use maybe green, the first step is to do this right here, f of x plus h. And so that is going to be 7x plus h squared plus 3x plus h. And I don't know if you noticed what happened, but I took the x plus h and replaced each x with it in the function. So that is the first step. The second step is to do the minus f of x part, okay? So then we're going to say minus f of x, which is just the original function, and that is all over h. And then it's just a matter of doing all the work and getting it to work out right, okay? So let's take our time and see if we can get this worked out. Here we go. 7x plus h squared means x plus h times itself. The 3 can go ahead and distribute. So plus 3x plus 3h. And the minus can go ahead and distribute. Minus 7x squared minus 3x all over h. And then we're going to have to do the FOIL method. That's going to be 7 first, outside, inside, last, plus 3x plus 3h minus 7x squared minus 3x all over h. All right, and because I'm running out of room, I'm going to have to do 2 steps at once here. So we're going to combine these like terms and distribute the 7 all at one time, okay? So that's going to give me 7x squared plus 14xh plus 7h squared. I notice that the plus 3x and the minus 3x will cancel. So then I'm going to have a plus 3h and a minus 7x squared all over h. And then the 7x squareds can cancel. And then I can factor out an h. Because all of the remaining terms in the numerator there have an h, and then I can cancel these h's. So my final answer is 14x plus 7h plus 3. Final answer for the difference quotient. Number 9, solve the following rational equation. And I can see that we're going to have to do a little factoring first, okay? So we're going to have 4 over and if I factor this trinomial, we're going to read the signs. The signs are both going to be plus. Oh man. X and x to make x squared, and then numbers that multiply to make 15. Numbers that multiply to make 15, that add and make 8. What numbers multiply to make 15 that add and make 8? 5 and 3. Minus x plus 3. That's not going to factor, but I'm going to leave some room here because I know I'm going to need to add to it. And then we're going to have 1 over 3x plus 15. I noticed that there's a common factor of 3 that I'm going to factor out, which will leave me 3 times x plus 5. All right, so now that I have every denominator factored that will factor, the next step is to see if we can find a common denominator, okay? So looking at the first denominator, I noticed that there's an x plus 3 and an x plus 5, which means the second denominator needs an x plus 5. Whatever you do to the bottom, you have to do to the top. And the last denominator needs the x plus 3. Again, whatever you do to the bottom, you have to do to the top. And now that all 3 denominators are still not identical, because this last denominator has this 3 here, okay? So that means that this guy needs a 3, and the first one needs a 3. And so now that all the denominators are identical, you can effectively cancel them out. And so that's going to leave me only the numerators, which is 12, minus 3 times x plus 5 equals x plus 3. That's my new equation. I just need to solve for x. So we're going to distribute the negative 3. And that's going to give me minus 3x minus 15, x plus 3. And then what next? Let's tell you what. Let's bring this x this way. And let's not do that. Too many things in one step, okay? Let's do this instead. Let's combine like terms. So negative 3x minus 3, x plus 3. Now let's bring the x this way and the minus 3 this way. And so that's going to give me negative 3x minus x, and that's going to give me 3 plus 3, because the negative comes over and makes it a plus, okay? Combine like terms, negative 4x equals 6. Divide by negative 4, and we do want to write that as a reduced fraction. Reduced to lowest terms, that is negative 3 halves. And that answer does not make any of the original denominators 0. So that is a valid solution. You probably do need to check your answer on that one, okay? And we've got one more problem to look at before we shut this video down. We need to solve a radical equation, okay? Saved easy stuff for last. So we've got 5q minus 4 under the square root. Whoops. Like so. Equals 4. When you're solving a radical equation, the first thing you want to make sure of is that the radical is isolated. So only square root stuff on the left. And then to get rid of a square root, you square it. But whatever you do to one side, you have to do to the other. So we're going to square both sides, and the square and the square root cancel. That's going to leave me 5q minus 4 equals 16. And then 2 more steps, and we're done. Bringing the negative 4 over makes it a plus 4. 16 plus 4 is 20. And divide both sides by 5. Final answer, q is 4. And you can plug that back in and check it if you like. 5 times 4 is 20. 20 minus 4 is 16. And the square root of 16 is 4. So it does check out. And that's it for the first part of the practice final exam for college algebra. If you have any questions, feel free to put them in the question comment section below. Or you can text me. And thanks for watching.